The Earth has curved sea level.
On your knees, acknowledging the linear distance, perpendicular elevation, and flat Earth prerequisite elevation angle.
Yeah, okay. On a local scale, I will acknowledge all of that. We measure Earth flat. And yes, local land surveys use flat approximation for convenience. The elevations are measured from the flat Earth headquarters. Okay, look. Land surveyors do often use flat plane approximations over short distances. 6,000 feet above sea level means the average level of the ocean, and sea level is assumed to be flat ground forever. Since elevations are measured as vertical distances from sea level, measuring a mountain's elevation, it assumes that since elevations are measured as vertical distances from sea level, and sea level is assumed to be flat, then the whole system collapses if Earth is curved. The Earth has curved sea level. Okay, look. Land surveyors do often use flat plane approximations. Every major bridge or tunnel or transcontinental railway use flat approximation for convenience. Linear measurements require flatness. Miles only make sense on a flat plane. By using miles, directions and measurements, you're secretly a flat earther. And yes, local land surveys use flat approximation for convenience. Especially for locations many miles apart, use flat approximation for convenience. Even manual levelling over long distances, normal trigonometry gives good approximations. Trigonometry doesn't care what shape you're on. It's just relationships between angles and lengths. Used by pilots and astronomers and GPS systems, you can absolutely apply trigonometry. In the case of this diagram here, 50 kilometers, so normal trigonometry is absolutely valid. Earth being measured flat. And yes, local land surveys use flat approximation for the angular size of Pikes Peak from that position is 2.36 degrees. This is basically the angular size you expect on a flat Earth.
Here.
You absolutely do calculate these degrees when talking about how high a mountain appears from a certain location. We measure Earth flat. That's how line of sight works. Elevation angle is often measured by calculating it using height and distance, just like we did earlier, only on a completely flat surface.
What you measure it.
The angle to a mountain or a tree depends on height difference and distance. If you claim the Earth to be flat, both are which measurable, predictable, and calculable, and you can absolutely test that. Nathan's saying it just is what you measure Earth flat.
On your knees, acknowledging the linear distance, perpendicular elevation, and flat Earth prerequisite elevation angle.
Yeah, okay. On a local scale, I will acknowledge all of that. The Earth is flat. Measuring the shortest path between 2 points. Over small distances, you can use straight line approximations. We measure Earth flat. We're all done and dusted for another one.